Okay, so again, if you want to pause this, so then that way you can actually see the question, you can. Otherwise, I'm going to go ahead and start. But how do you determine if a bond is going to be polar, covalent, nonpolar, covalent, or ionic? And then provide an example. So this one should be relatively straightforward. We know that in between or above 1.7, so greater than that 1.7 of a difference in electronegativity is going to give you an ionic bond. Okay. If it's between 0.5 to 1.7, that's going to be a polar covalent. And then if it is less than 0.5, we know that's a nonpolar covalent. Again, you determine this through differences in electronegativity. Uh, an example is that oxygen is a 3.5 electronegativity, and hydrogen is actually a 2.0. So if you have a bond between an oxygen and a hydrogen, you're going to end up with an electronegativity difference of 3.5 minus 2.1, which equals 1.5. If you go up here and look, that is a polar covalent bond because it falls in that range right there. Obviously, that would be a great example for a polar covalent. And you can choose any other two examples that work well. So for a nonpolar covalent, a common choice is to pick two uh, elements that are the same, such as carbon to carbon. Well, obviously, they're going to have the same electronegativity, which happens to be 2.5. So if you took 2.5 minus 2.5, you're going to get 0. It's going to be a great example of a nonpolar covalent bond. And then you can always choose a salt. That's always a good one for ionics. So we could just pick NaNCl, and they always have a much greater difference than 1.7. And obviously, you can just look at that table of electronegativities that was given to you for the test, and then choose from there. If you have any questions, then you can ask me about them later.